Hey there, physical science students. Ms. Ruach here. Let's talk about some acids and bases. These are things you come across every single day in your life. So, properties of an acid. Well, when an acid is dissolved in water, it's going to ionize, which means it's going to break apart and form ions. Okay? A compound that's an acid is one that's going to increase the number of hydronium ions. Okay, so hydronium is H3O plus. It might look a little bit like water, right? So let's say that we have HCl, which is an acid, hydrochloric acid. We put that into water, it'll break apart into hydrogen ions and chlorine ions. All right, well, the hydrogen ions here are going to take themselves and attach themselves to a water molecule, which makes it H3O plus. Okay? So anytime you put an acid in water, it breaks apart and increases the number of hydronium ions, and that's what makes it an acid. All right, so different properties of acids. They have a sour taste. They are good conductors of electricity because they break apart into ions, and remember, to conduct electricity you need electrons. When you put blue litmus paper in them, they turn that blue litmus paper red. They are corrosive, and they have a pH below 7. A strong acid is one that's going to completely ionize. It's going to completely break apart into ions. And a weak acid it's going to break apart, but it's not going to completely ionize. It just partially ionizes. Okay? So if it completely ionizes or breaks apart into electrons, we call that an electrolyte. So these would be strong electrolytes, and then these would be weak electrolytes. Okay, you've heard of electrolytes. They say that they're in your Gatorades and your Powerades. All right. Properties of bases. Bases are compounds that are going to form hydroxide ions when dissolved in water. Now, we've heard of hydroxide. Hydroxide is OH with a negative charge. Okay. How can they do that? Well, they'll take the water molecule and it breaks apart into H's and OH's. Right? And then if we put, I don't know, yeah. If we put a base in there, I don't want to do NH3. My brain's not functioning right now. So if we put a base in here, what it's going to do is it's going to break apart into its ions, and it'll take on this and form a base. So properties, some properties of this, we have a bitter taste to it. It's not sour, it's going to be a bitter taste now. That doesn't mean I want you to walking around tasting everything, because that's dangerous as well. But if you happen, there's foods that have bases and acids in them, and if it has a bitter taste to it, it's got a base in it. They feel slippery. Okay, have you ever spilt bleach on your fingers and your fingers feel slippery? There you go. They conduct electricity. They turn red litmus paper blue. They are corrosive, and they have a pH that's above 7. Okay, strong bases will completely ionize. Those are strong electrolytes. And weak bases will not. They don't completely ionize. They only partially ionize, so those would be weak electrolytes. Okay, a lot of people confuse strong and concentrated. They say they're the same thing. Well, guess what? They're not. Okay, concentration is talking about the number of solute particles in a particular amount of solution. Okay, so let's see, juice. Okay, you can go to the store and get the frozen juice, and that's concentrated because it's really syrupy, it's really thick, it doesn't have any, it's not watered down, right? So if it's concentrated, it has a large amount of solute in it. If it's dilute, it has a small amount of solute in it. And how does it have a small amount of solute in it? By adding more solvent. Okay, so if you get the concentrated juice from the freezer, and in order to make it, you have to put water in it, right? So you're watering it down, you're diluting it. All right, strong isn't talking about concentration. It's not talking about how much there is. It's talking about whether it completely or partially breaks apart into ions. So if it is a strong electrolyte, it's going to completely ionize. And if it's a weak electrolyte, it only partially ionizes or partially breaks down. Okay, when we talk about acids and bases, we talk about them in terms of pH. So what is pH? Well, pH is a concentration of hydronium ions. Okay? Remember, H3O with a positive charge. All right, so the concentration of hydronium ions determines if it's an acid or if it's a base. All right. If the pH is less than 7, it's going to be an acid. If the pH is greater than 7, it's going to be a base. And if the pH is 7, it's neutral. Okay. Over here we have a chart of some different stuff that's here. Battery acid has a pH of 0. Hydrochloric acid, you can find that in your stomach, has a pH of 1. Lemon juice and vinegar, pH of 2. Soft drinks, look at that, pH of 3. Tomato juice and acid rain, pH of 4. Black coffee has a pH of 5. Your urine when you go to the bathroom and your saliva has a pH of 6. All right. Pure water, your blood is also around a pH of 7. Seawater is a pH of 8, so it's a little bit more basic than baking soda. Ammonia is a pH of 11. Soap, usually anywhere between a pH of 10 and a pH of 12. Bleach is a 13. And liquid drain cleaner, you don't want to touch that stuff because it's a very basic solution. It's a pH of 14. Now these down here, these pH, the bases, they're just as dangerous as these acids. Okay? They're just as dangerous. So you really don't want to get things on you that's too far away from a pH of 7. The further you get away from that pH of 7, the more dangerous it is to you and your person. It's more dangerous to your skin. It's more dangerous to your mucous membranes, right? You know what your mucous membranes are? Your eyes, your nose, your sinuses, your mouth. Okay, so you really don't want to mess with those too much because they are dangerous. Just because it's a base doesn't mean it's not dangerous. Okay. All right, so how do we determine pH? Well, you can use a couple different things. We call them indicators. You can use litmus paper, you can use pH paper, or you can use a pH meter, and you just stick it in the solution, and the pH meter is an electric meter, and you put it in the solution and it actually gives you a number. The litmus paper and the pH paper is you put it in the solution and it will show up a color. And the color will tell you what pH it is. All right, I think that's it. There it is. And I'll see you in class. Oops.